The people came to know how to write the SQL statement, but sometimes they are not understanding what is the internal process of the SQL or PLSQL, how SQL is running internally. So let us see the, one second, let us see the basic architecture of Oracle. Yes, Kapil. Is for basic SQL and database. Okay. So this is the basic architecture of the Oracle. We will be focusing only on this area, shared pool. There is every software, Oracle also requires the memory to execute. So the moment the Oracle database is start, Oracle background processes and some of the Oracle internal memory will get loaded into RAM. Then some of the information, Oracle internal information, we call it sometimes metadata information, will be loaded into the memory. That memory is called system global area. And within the system global area, we have something called shared pool area. Within shared pool, there is something called library cache. So each SQL we fire, it will be cached into this memory area. You can see here, select star from employee. If I fire another query, then select star from department. Anything like any join, PLSQL, any code which we fire SQL which successfully parsed. First of all, the syntax, semantic, everything will be checked. So after successful parsing, then only this will be stored into the memory area. Let us see one flow chart. Now you came to know about the library cache. So if you log in as a sys user, this is the tool I am going to use. It's called sys. I'm giving the password and I'm logging as a sys user over here. So like this is a flow chart for this execute SQL statement. Means any SQL statement which needs to be executed. Oh, you cannot see my screen. All of you can see my screen? Oh, good. Okay. So execute SQL statement. So if the SQL statement is parsed successfully, parsing means we check whenever we write a SQL statement like this, just select star from EMP. Then we execute this. This is called successfully parsing. It means there is no syntax error. That is why we can see the data. Select something. Instead of the letter T and I am trying to execute, this is syntax error. So whichever the SQL which is parsed successfully, that can only be stored into the library cache. Only those SQL can be stored into the library cache. So that is why I am checking, is a statement in library cache? If the statement is already there in the memory, library cache is nothing but memory. We will see how to see the library cache data. If that SQL is already there in the memory, then we will call it complete the soft parse. The soft parsing is done. Or a soft parsing means that syntax is everything is already checked. Like I am a user, I logged in by using the Scott schema. So do I have permission to access this table? Is this table exist there in the database? All this kind of check will be done in the parsing phase only. So the parsing phase mainly divided into two parts. One is called syntax parsing, second is called semantic parsing. Within syntax parsing, we check all the syntax of the SQL. From is written properly or not. After select, there is a star, between select and star word, or between select and column name, there is a space or not. These all will be checked in the syntax. and the object which we are going to access is employee table. Is this object exists there in the database under escort schema, or whether the escort schema has the privileges to access this object? These all kind of checks is done in the semantic check. These two combined together, we call it parsing. So if that SQL statement is not parsed, then we call it hard parsing. Then the first time SQL statement will be parsed by the SQL compiler. After that, and if the SQL statement is already there in the library cache, then that is called soft parsing. Once it is parsed successfully, the first time obviously it will go for the hard parsing. Then it will be cached into the library cache. Okay. Then after that, Oracle internal CBO, there is very intelligent things associated with Oracle internals. We call it cost-based optimizer. The name itself defines like it is an optimizer. It prepares always the execution plan internally. Okay, suppose one SQL is, suppose it's similar like this. There is an intelligent guy. If I assign a job to him, he would be in the position of saying like this job will be processed in which way so that it will be faster and the result will be given to you. So that guy is called CBO, cost-based optimizer. It prepares internally depending upon like how many record it has, who is the user, what is the shortest path to access the data, what is table space, what is the size of the table space, what is the size of undo table space, or we call it rollback segment. There are so many parameters based on which this guy CBO prepares the execution plan of the query. Once the execution plan of the query is done, then Oracle fetches the information. So after n number of phase, after seeing the n number of phase, CBO will choose one way, and after that it will try to fetch the data from the file. Because Oracle is a RDBMS system, every software will finally hit the file because everything needs to be accessed via the operating system. Operating system understands files. So once the SQL is parsed, it is cached into the library. Oracle prepares one good way of finding the data or fetching the data. We call it execution plan. We call it statistic gathering also. We will see it in a very different chapter. So everything is done. Now this time is to see the data. So in each table is a logical structure, but within the table the actual physical things will be data file. Each data file is divided into a smaller unit. We call it data block you can say. So each block we can see in what is the size of the data block. You can see into this table. Select star from V $parameter. This is a controlling table. The Oracle, while preparing the different ways of execution of the query, or you call it plan, Oracle sees this table. What are the things set in this table? So we were talking about, you can see DB block size here, this row. DB block size is here 8192. This is in bytes, means this is 8 KB. So the each block size will be 8 KB. So if the table will have suppose 5 KB of data, so Oracle will create 8 KB block. I'll show you one second how it looks. Block will be looking like something like this, a table, a cell. 8 cell data. If you see 8 KB means there will be 8 cell inside. Each cell may be having some data of, suppose the employee number 1 data would be here. Maybe employee number 2 data got adjusted over here. And this cell may be contain employee number 3 data. This cell may be contain employee number 4 data. So the moment you define the database you create, you have to define the data block for your database, and we set it 8 KB, means 8 cells. So once you run the SQL, everything is done. Now the data is fetched in the form of data block, and we can say the data block is the smallest unit of the data, the storage of the data. So the whole block will be loaded into the memory RAM. So that depends upon the size of the data block also. If the data block size is 8 KB, so obviously it has to go every time to the hard disk, fetch the data block, fetch the data within the DB, and push it into the RAM. So can you imagine if you have created the DB of 16 KB data block, obviously the more information will be cached into the memory, the more data will be cached into the memory. So it depends. So that is why sometimes people says if there is a very huge table, try to push that table into a table space which contains 16 KB data block, which contains 32 KB data block, so that the IO will be less. Means Oracle will not have to go every time to hard disk. Suppose there is 100 KB records need to be fetched. So if you are defining 16 KB, how many times you have to go? 16 into some. 16 5 is suppose 80. So it has to go 8 times. If you defines 8 KB, obviously this has to go around 10 times, 12 times. So that depends upon the data block size. Your IO will be reduced. So that is why here I am showing here are the blocks of the table are cached into the buffer or not. So similar like the SQL statement is cached into the library cache, similarly all the data block will be cached into the buffer cache. They call it DB buffer cache size. Okay, so every size will be controlled here. We can increase or decrease the size depending upon your database size. If the database size is more, number of users are more, we can tweak this parameter. See, DB cache size. This is the DB cache size. Here, by default, 0 means Oracle will take care of this depending upon the availability of the RAM size. If that server is not hit by many users, if many processes are not going into the server, then obviously Oracle sees, suppose if 8 GB RAM is there in the server, how many RAMs are available to execute this select statement. So Oracle decide internally. If you fix it, then suppose you have allocated 2 GB. So every data block will be stored within 2 GB only. If it is going beyond 2 GB, obviously there will be a virtual swapping. Means if 2.5 GB, so 0.5 GB will always be there in the hard disk and 2 GB will always be there in the RAM. This is normal operating system concept. So by setting it to 0 means we are telling Oracle, let Oracle do all the memory calculation at runtime. They will not bother about it. By setting it to this value, user defined value or DBA developer defined value, then we can say, okay, this particular things means if you want to cache more data block in the memory, obviously this parameter need to be increased more. Okay, so we have done if all the block is cached or not. If it is cached, then it will directly fetch rows. If it is not cached, then it will cache the data block in the buffer cache, then it will fetch rows. So sometimes you see, you can do practice in your office also. If it is a big query, that query is a lot of join with T1, join with T2, join with T3, and there are a lot of complex join over here. There are many where condition, where exist, another subqueries, select one from blah blah. So many things. If you run this query the first time, this query takes around 1 minute of your time, 1 minute of your time. If you run this query second time, this query may come in a fraction of second. People understand this, but many people don't understand the logic behind it, because the first time when you are running the query, it need to be parsed. Parsing means checking syntax, checking the user privileges on that object. So everything will be checked. That checking takes time. Similarly, If the data is not there in the buffer cache, because after checking, Oracle prepares its finest way to fetch the data out of 10 ways. Suppose one way is chosen, then Oracle will fetch the data in a form of data block, which is the smallest packet of data, you can say. Then it checks whether that packet is already there in the RAM. So if something is already there in the RAM, it will always be faster than if it is in the hard disk. So you came to know how Oracle internally works, how Oracle execute the SQL statement. I can see that there is one. I'm using PL/SQL developer. You can use SQL developer tools also. This is just a tools. $SQL. So see, I ran this query. What is the query? I ran one query, select star from EMP. Okay, let's give one alias E1. Select star from EMP E1. Let's search this text into as a sys user, where the first, you can see the first column, SQL underscore text, like I'll say %, I can search it %, let's execute. There are many even would be there, so better if you'll dept no is equal to 10. So let's execute this query and do for dept no. See here, I ran this query, right? EMP even is the alias dept no. So now if I ran the same query from the another session, or someone else ran this query, and what he did, he wrote everything in capital letter. Everything from means all the keywords. What is going to happen? Oracle will not understand this query and this query are same. Even everything is same, because Oracle SQL query is case sensitive. Not in terms of case sensitive, in terms of syntax and semantic. It is case sensitive in terms of caching into the memory. So Oracle sees the first letter is in capital S. Is there any capital S there? Yes, there is S. Suppose there is no S. So Oracle will identify this query is completely different from this query. So it will try to cache it again. So if you try to search department number 10, you will be seeing only two query. One query which I ran, obviously this is also a query. Even we are checking, even we are using this query for our checking purpose internal, this also will be a cached. So if we are not seeing any select statement in uppercase over here. Let's run this select statement. Now you try to execute. See, your third SQL statement also appears. It is proof that this select statement is not identical in terms of performance of a query. Oracle parse this statement also, Oracle parse this statement also. But if you run the same statement again and again, you will see there is no other record for this one, because Oracle checks S capital, E capital, L capital, all these statements are identical or already there in the library cache. This flowchart will say is statement in library cache. It means is statement is there in the $SQL. $SQL is a view which will help us to see the library cache data. We can see like here in the shared SQL area, what is the SQL statement which is there. So S capital, E capital, L. You can see select star from imply. Same thing I stored here. So you can imagine like any company, every company says like if you are a fresher or if you are experienced, every company has its own coding standard, internal coding standard. It always says always follows that all the keywords of the Oracle should be in the uppercase. They may say sometime. They may say all the table first character of the table, all first character of the table should be in the uppercase. Let's do in the uppercase E. Let's execute this also. Will Oracle identify this query and the previous query is same? No, because here E becomes in uppercase. So if you will go here and check in the library cache, you will see another SQL statement. See, because of capital E here, you can see. That is why you can imagine if thousands of SQL will be running during the day, how much performance it will hit. So it is always understand, we never care about writing the SQL query. They always think that whenever, whichever the way we are comfortable, we write sometime in select in capital, they write sometimes select in lowercase, but Oracle parse each and every character. That is called hard parsing. That will take time. So it is better you follow the same nomenclature, or you can say you follow the same naming concept, or you're either in the uppercase or in the lowercase or in the next case, like S should be always be in capital. Each keyword of Oracle will always be in capital. So that is why company says always follow the coding standard. It always helps in terms of internal performance also. So there are many things about it. So I just tried to explain you. I have chosen a very basic topics. It will helpful for the experienced guy or the non-experienced guy also. Let me open one course content over here. One second. This is the course content for the basic. I need to add some of the, because the topic over the, because the main agenda of this course to learn the basic database and the basic SQL statements. Basic about the Oracle. You can say including SQL, PLSQL, you will learn basic about the database. Like suppose, for example, there is one basic. How would I come to know in a particular schema how many tables have more than 15 records? How would you come to know? You have to go through each table like select, count, one from EMP. So I came to know, sorry, from EMP. So I came to know, okay, EMP got 14 records. Let's see the another table. So since I remember the table name, so I can write it down here. From DEPT. Let's execute this table. So I came to know this is 4 table. If there are 500 table or 1000 table in your project, in your schema, then how would you know? So there is very basic SQL table. Oracle has its internal tables which will help us to create or to fetch more information about the object we created. So we call user underscore tables. Okay, this is the tables from user underscore tables. Okay, this is the table, and there is one particular column called, you can see there is one particular column. One second. Is number of rows. Num underscore rows would be here. Num underscore rows, right? See here. This is the num underscore rows. So we can say num underscore rows is greater than 10. So Oracle will give all the table name here. See, EMP table, PLSQL profiler data table. I have 2 tables which contains more than 10 records. Similarly, there are many things, many information that Oracle captures internally while creating the table. So you'll come to know in the different lesson how Oracle behaves. So this is the course content of the PLSQL. Like what is PLSQL, history of the PL, so many things. I think this will be shared in the next demo session. You will come to know all about. Means the main important of this, so whatever the things that you are doing at your end, it's not a trial and hit. It shouldn't be a trial and hit method, trial and run method, like trial and get method. No, you should be perfect in your select statement, or you should be perfect in your knowledge. It's not always been a dubious Yeah, kind of thing. So whether it will come or not, shall it come or not? Don't ask a question to yourself. You should be confident on and clear your logic. That is the most. So I'm going to unmute all of you. If you have any queries, let me know.